A major project to renovate the cooling water system for Hong Kong's Black Point Power Station has demonstrated the benefits of a shore-based solution for such tasks. Dutch underwater construction specialists DCN completed a fast-track 90-day contract for Castle Peak Power Company, Capco, 3 days ahead of schedule. The 2,500 megawatt Black Point Power Station is owned by Capco, a joint venture involving China Light and Power and Exxon Mobil Energy. It is located in Hong Kong's northwest New Territories. It is one of the world's largest natural gas-fired combined cycle power stations, representing an investment of some 24 billion Hong Kong dollars. Units 1 to 6 were commissioned in the 1996 to 1998 period, while Units 7 and 8 will be commissioned in 2005. Renovation of Black Point's cooling system was essential due to the extent of the marine growth within the culverts. This restricted the flow of cooling water, especially at very low tides. The station uses a siphonic once-through direct cooled system with a submerged offshore intake. Cooling water is taken from the sea by the two intake culverts. The cooling water pump room has 2 forebays, each connected by a 400-meter-long twin-cell culvert to the offshore intake. Each twin culvert cell is formed of 10-meter-long sections of precast concrete with a width of 6.4 meters and a depth of 3.6 meters, installed in a dredged trench. Internally, each culvert cell is 2.6 meters square. DCN's scope of work included removal of marine growth, the cleaning, restoration and sealing of 146 culvert joints, the removal of an existing dosing line and its replacement by a new 3-inch hypochlorite line and diffuser rings. Manual cleaning of the culverts was out of the question, for safety reasons and due to the tight project deadlines and fact that the marine growth was up to 40 centimeters thick. DCN have a reputation for innovative approaches to problems. Faced with the task of cleaning and repairing, they turned away from conventional diving and developed instead the concept of remotely operated cleaning machines, or ROCMs, and drivable wheeled habitats for the divers. DCN won the contract in mid-2003 in the face of stiff international competition from 9 other contractors. DCN's bid was the only proposal based on a shoreside solution, and Blackpoint saw the first operational deployment of these sophisticated machines. All power supplies and operation were from shoreside, with no costly marine deployment and no weather downtime. When DCN won the contract, it immediately started design and construction of 2 ROCMs and 2 habitats. These sophisticated units made project completion within 90 days, a viable proposition. All the equipment was designed, built, tested and commissioned in just 12 weeks. The work involved best efforts by mechanical, electrical, hydraulic and software specialists. The input of diving and insurance expertise was also critical. Today, they are the most advanced automated culvert cleaning machines in the world. While designed for work in rectangular culverts, they can be reconfigured for operations in pipelines and elsewhere. A key advantage of this approach is freedom from weather downtime risks, a vital consideration in the context of a costly half shutdown of a power station for fast cleaning. Another major benefit is production efficiency. Here, the ROCM has the advantage of avoiding batch operations. The machine removes, crushes and pumps ashore marine growth in a continuous process. The custom-built ROCMs consist of a 20-foot control container, an umbilical and crawler unit. The control container has 2 rooms, one houses electrical systems, while the second is a 3-panel control station. One panel carries switching, while the second operates the crawler unit, and the third presents the main displays for the crawler unit's cameras and instrumentation. The crawler unit consists of tracks, frame, winch, cleaning arms and heads, and a bottom-mounted shredder unit to crush and dispose of the marine growth as it is removed. The unit features 2 cameras, 4 lamps and various systems including 2 hydraulic units and a dredge pump. The crawler unit is equipped with 3 arms tipped with rotating cleaning heads. These arms function in both the horizontal and vertical planes. Each head consists of 2 counter-rotating steel units. The ROCM's guide wheels prevent contact damage to the culvert's internal surfaces. The shredder has counter-rotating crushers. Crushed debris is pumped ashore by the dredge pump via a 5-inch discharge line to a settling pond. The ROCMs were controlled by the ROV pilot ashore. Each unit has both low and high-speed modes, 5 meters an hour and 200 meters an hour respectively. Low speed was selected for the cleaning role, while high speed was engaged for entry and exit. The ROCM's cleaning heads can be operated manually or in automatic mode. The habitats are also genuinely unique. They use a water hydraulic power system to avoid pollution. The drive wheels operate against the side of the culvert, not the floor, and can be hydraulically adjusted to operate in different widths of culvert. Air, power and communications are supplied through an umbilical, just like a diving bell. And if things go wrong, the divers can survive inside the habitat for at least 24 hours. The habitat acted as a transport shuttle for the diving teams and provided a dry work environment and a safe refuge. One diver stayed in the habitat while a two-man team worked outside. There were 4 teams of divers, working 24 hours per day, with 2 teams on each shift working in separate culverts. Operations were run from a state-of-the-art diving and habitat control room with a decompression chamber on standby in case of any incidents. In over 7,000 hours of diving, however, there were no accidents or decompression problems. Work at Black Point continued round the clock, with the Rocm cleaning in one go at a sustained rate of 5 meters an hour. Behind the Rocm, the habitat and the diving teams operated in the cleaned culvert. The sequence of operations at Black Point commenced with manual cleaning of the entrance to the culvert and positioning of the Rocm. As the Rocm began to clear marine growth, the old dosing line was removed, brackets were positioned for the replacement line, and joints cleaned and sealed. When the Rocm had advanced 30 meters, the habitat entered the culvert and made its way towards the cleaning machine, which then advanced another 30 meters. Cleaning, removal of the old dosing line and installation of its replacement, together with high-pressure water cleaning and sealing of joints, continued until both vehicles reached the end of the culvert. They then returned to the forebay.